Hi, thanks for coming. My name's Chris. For those of you who don't know me, I'm with Michael Dyson Associates. We're a multidisciplinary practice, largely specialised in social housing, but do commercial as well. That's actually the last time you'll hear me talk about my employers, because what I'm going to talk about is some research which really started about nearly 30 years ago and covers 4 different practices. And you're not here to hear me deliver a sales pitch. It's about research. So, sustainable building materials. And after the last 2 presentations I've heard, this I hope will be quite apposite, to tell you the truth, because maybe I should retitle this Regulation and Reality. We've heard a lot of people talking about how they're attaining sustainability and how they're getting high scores and really good grades on assessment systems. But how do you know that's real? What does that mean? How is that quantified? I don't know. So why sustainable building materials? Why even bother? Well, if you can look at this graph, this demonstrates the lifespan of a building, 0 to 60 years, which is roughly about what we aim for. And this is the cumulative energy involved in that building in gigajoules. And this is the embodied energy. This blue line is what goes into the building. When you construct a building, that's the energy that you use to actually put it up. And that stays roughly the same. You construct it, it stays the same, doesn't change, unless you change the building. And then you've got your operating energy, everything you use to heat, cool, run the building. If you've got a particularly inefficient building, over the years it builds up and up and up. And at this point it will cross that embodied energy line. If you're a little bit better building, maybe down here, it'll cross that. And an even better building down here, it'll cross it almost to the end of its life. Now, believe it or not, we're getting quite good at creating efficient buildings with efficient operating costs. Building regs is able to make you do that. So sooner or later, if we carry on, this line is going to drop down here. And you'll be able to see that by the end of the building's life, most of the energy going into that building in aggregate over its lifespan is here. That's where it is. Not in the running costs. It's what you're putting into the building to make it stand up. Now, just as an example, I've heard somebody mention about large-scale timber frame actually in the previous presentation. And
Do you mind if I just sit with you?
So that's it. Anyway, example. This is a 7-8 storey block of flats in London that was completed maybe 5-6 years ago by Marshall. And it was constructed, the structural frame, from cross-laminated timber. Bits of wood stuck together in panels. It was used instead of a reinforced concrete frame. And there was a study done to show the comparison between what would happen if they used a reinforced concrete frame, which the contractor was used to using, and cross-laminated timber. And it used 1,500 cubic metres of timber about. But in actual fact, by using timber, it saved 892 tonnes of carbon. And if you take into account sequestered carbon, because it's timber that's growing, there's another 2,113 tonnes. Now that's equivalent to 29 years of operational energy for a building of that size. And if you put 20% renewables on it, which is kind of a guideline at that time in London, it'd take 144 years to save that. Now in UK legislation, that is not covered anywhere. If you work to building regs, this operational energy they're asking you for, they're asking you to work out your carbon and your air conditioning, your heating, your insulation. It doesn't ask you to build it out of anything. So if we carry on the same way, going back to that graph, in a few years, what's building regs actually doing? What's it actually asking you to do in terms of sustainability? Not addressing the main issue. So that's why sustainable building materials are important. But what is a sustainable material? If you start saying I'm going to construct my building out of sustainable materials, what do you mean? How are you going to assess it? How are you going to measure it? What is sustainability? Is it something with low embodied energy? or low embodied carbon, because they're not actually the same. You can have something that uses an awful lot of energy to produce, but the energy used to produce it might be zero carbon. Could be nuclear, depends on your opinion. Lots of people don't like it, but it's fairly low carbon. Might be hydroelectric. It might be quite a high energy material like aluminium, which uses hydroelectricity to produce. Is it something that saves energy in use? We create highly insulated buildings to save that operational energy, but half that insulation we use is petrochemicals. You can't eat it. It never goes away. Is that sustainable? Is it something that's non-polluting? Is it something that's non-toxic? Is it something that's recycled or recyclable? Because that's different. We hear lots of things about, oh, everything can be recycled, but does it get recycled? Will it get recycled? Does it just end up in a tip somewhere? Is it something that there's not much of? Resource depletion. I don't know if anybody knows anything about tungsten, but there's a finite amount of tungsten in the world, and it's getting smaller and smaller, and basically the modern world doesn't run without it. But there's not many people actually trying to save its use. Or is it social issues? I've heard a lot about social issues in a presentation this afternoon. Is that sustainability? It can be any of those, or all of those. You have to decide. There's no system to actually tell you what to include. You might decide that, yeah, okay, embodied energy, embodied carbon is the key, because that's the kind of impact on climate change a lot of the time. And then you've got to try and find that data. And that is really difficult to do with any degree of accuracy. There's a few kind of sources. One of my favourites that I've looked through in the past, and it's fairly old now, is the Inventory of Carbon and Energy, which was created by the University of Bath. And it's quite a lengthy document. And it splits down, I don't know if you can tell here, various materials into embodied energy and embodied carbon. Remember we talked about the difference. And it makes assumptions. Looks at aluminium, typical of the UK market. It makes an assumption about the recycled content in there, because you really can't tell what amount of recycled material in your aluminium you're going to get when you order your windows. And it makes just assumption basically on carbon and energy. And you can go through that and number crunch and look at all the numbers and try and add up and try and assess something. But all we have to be aware of is that the people that put this together, Dr. Jones, Craig Jones and Jeff Hammond, they were stuck trying to find that information to start with. When I first started looking at sustainable building materials, I used to ring up building manufacturers and say, can I speak to someone that can tell me about your energy content of your materials? And the phone went silent because there was nobody there to tell you. And that was maybe about 10, 15 years ago. And at least now they sort of panic and say, I'll try and put it through to somebody. But you've got to try and find out where all that information is coming from. Aluminium, which often gets a bad press because it takes a lot of energy to produce, doesn't take much energy to recycle. And because we eat so many crisps and drink so many fizzy cans of pop, there's quite an active recycling scheme to recycle aluminium. So believe it or not, it's one of the more developed recycling schemes that there are. But say steel or anything else with recycled content in it, it's very difficult to tell what is in there in reality. But somebody somewhere along the line in the assessment systems that we're talking about has made a decision, and that's what the IC has had to do. What you could do is to have faith in somebody else to do it for you. And a lot of that faith, commercially, often comes down to BREEAM, which you might all be familiar with. And part of BREEAM comes down to the BRE Green Guide to Specification, which is an online tool. And you log into it and you create an account and it asks you what your building is, is it industrial or domestic? And you look for an element or a system and you try and look for a material with a particular rating. The Green Guide runs from A+ down to E or F or G or something, showing how good or how bad it is for a particular material, particular location. So it says 2008, but it hasn't really changed. Building types industrial, insulation, and this is for EPS, expanded polystyrene. Stuff that, I don't know, you order something from Amazon and it comes packed in it. And the Green Guide takes these categories, various bits and pieces, its effect on climate change, effect on water extraction, human toxicity, ecotoxicity to fresh water, and it gives them a rating. You might be surprised that petrochemical like EPS has got an A plus for human toxicity. I've never had it for tea. But that's what it does, and then it gets that you get an aggregate score out of it that it comes up with, and the summary rating could be A plus. But the thing to bear in mind is that those ratings don't take into account end of life situations. They're manufacturing. So yeah, it might be not damaging to actually produce that, but the VRE Green Guide doesn't take into account what's going to happen to it when the building gets taken to pieces, and the EPS will still be there. So anyhow, so you've looked through insulation, and you can look through a whole different sorts of insulation for your industrial building, and they're listed basically on a web page like this, and you might be surprised then that your EPS, expanded polystyrene, is wonderful and green, and it gets A plus rating, and it comes from oil, which is transported probably from somewhere in the Middle East. And you might be a little bit surprised that something like cellular glass insulation, which is largely made originally from sand, only gets a C. How odd. And you might even be more surprised that corkboard insulation, cork comes from trees, grown naturally, replenishes itself. Most of the world's cork comes from Portugal. The cork oak, stripped every 7 years, grows back. Only gets A. So what the Green Guide is saying here in this situation, cellular glass insulation made from sand, corkboard insulation made from trees, isn't as good as EPS made from petrol or crude oil. Why is that? I'm not saying it's wrong or bad, but why is that? Well, we have to go back to that list of categories, and it does try and take those into account. And that's what I mean about faith. You have to have faith that the BRE knows more than you do, and there's aspects that you might not actually consider. So, just a few more examples. Corkboard again there, only A. Straw bale, used as insulation, only gets an A. And I must admit, this is beyond me, this bit now. There'll be bits that I understand why they've got lower ratings. I'll come on to a couple that might not be obvious. But straw, it's just grown. It's almost a farming byproduct. You know, farmers used to try and get rid of it. And it's A, it's there. The other thing that's changed actually in recent years, when I actually started doing this lecture, sheep's wool, I think that was about B or C, which was, I found just weird. But it's come up to A plus because of a lot of hard work on the part of the industry. The reason that sheep's wool insulation only used to get B or C is that it was considered as a byproduct of the meat farming industry, particularly the upland sheep farming industry, which contributes quite a bit to erosion, lots of runoff, chemicals. Meat farming isn't particularly sustainable or particularly environmentally friendly, so sheep's wool got labelled with that. There you go. But now, and just an example down here, the killer straw board, which we don't use a lot of in the UK these days. Used to be very popular, still get it in Belgium for some reason. Made from straw, it is bound together with a kind of a cementitious binder. But it's a killer that, see, if you're after your high-rated BREEAM building. A few more examples. I don't want to sort of labour really on this, but this is an industry standard we're talking about. Yeah. So if your client comes to you and says, I want a BREEAM rated building and I want it to be outstanding, and your primary driver will be to get those A ratings. And your primary driver won't be to look at whether it's real or true or the straw comes from somewhere sustainable. It's getting that A rating. So, a couple of examples. Windows, for example, durable hardwood window. Assuming your hardwood, comes from somewhere reasonable. A plus, as you would expect. But what you might not expect is a PVCU window. Yeah? C, chlorine, that stands for. That was a poison gas in the First World War. Steel reinforcement, double glazed, PVC. Why? I haven't got an answer for that one. And this is how the PVC window is rated. Lots of A pluses. Human toxicity, and the one that I really like, interesting, waste disposal, A plus. That's not waste disposal of your UPVC window. That's what they do at the factory. the manufacturing process. That's not the UPVC that have all been taken out of somebody's house and dumped somewhere. It's the manufacturing process. This is the fatal flaw. Don't get me wrong, I haven't got a downer really on the VRE Green Guide because it's an industry standard. And without the VRE Green Guide, things would be worse. But at least it's a starting point for people. But going back to PVC, which we've got to talk about because plastic is one of the bugbears of the 21st century. You might have seen Greenpeace's recent campaign about how much plastic there is in the oceans, finding whales with 30 plastic bags in the stomach. It never goes away. We hear that our modern life can't be sustained without plastic. Maybe it's our modern life that's wrong, I don't know. So UPVC, well, partial recycling of a UPVC window is actually possible. You can reface a UPVC window with virgin material. You can do that up to 10 times. Not quite sure what happens on the 11th time. Goes away to boarding school or something. PVC, we talked about chlorine, 40% of global chlorine production. I don't know much about chlorine production, but I bet I wouldn't want to live next to a plant. But and in the UK we generate 3 million tonnes of plastic waste each year, and 23% of that is the construction industry. And our UK plastic recycling is about 7%. So where's it all going? Where's it end up, all this plastic? Well, here apparently. Henderson Island, South Pacific. Forget your images of Bounty adverts, Timotei shampoo and girls running wistfully with their hair blowing in palm trees. That's what you end up with. This was in The Guardian just the other week, actually. And on Henderson Island, in the Pitcairn group, there's the highest density of anthropogenic debris recorded anywhere in the world, 18 million tonnes. And 38 million pieces of plastic on this paradise-like beach. Why is it all ending up there? Because of this, something called the Gaia, or the Great Pacific Garbage Patch, or the Plastic Sargasso. There's a few acronyms for it. And because of the way the world's currents work, plastic breaks down. You might think it degrades. It does degrade, it doesn't biodegrade. It breaks into little shards, and it'll end up flowing through the watercourses, ending up in the sea, and eventually goes through all the currents. It'll end up here. This is where the world's currents end up, in the Gaia. This is like a dead area, and you get two areas as the currents go through it, and that's depositing all the plastic there. This is an example of water, ocean water, from the Gaia. That's another island in the South Pacific. Oh, there's some bottles. And just cause and effect, tying things together. You've got to think about things holistically. I heard that mentioned in the last presentation, and the plenary presentation from the gentleman who was showing us the shopping centre brought up one of his clients was Coca-Cola. So admirably is, taking space in a sustainable shopping centre, but they're selling these. So we can try as much as we want to create sustainable buildings, but it's far more of a holistic problem to solve. Anyhow, back to this. Finding more information on sustainable materials. Where can we find it? Well, we've talked about the BRE Green Guide, but if you want to go beyond that, there's quite a lot on the internet, and there's some good websites and some good information, but none are exhaustive. You can't just depend on one source. GreenSpec is one of my favourites. Started off as very small, it's expanding. It offers information on products, design, and it's got something called a PASS system, which is yet another assessment system. But it tries to look at the practicality of using sustainable materials. So rather than just saying, yes, we're going to give these A ratings because it's made in a factory somewhere, that's nice, we've got to look at how this is used on site and what happens at the end of it. And unfortunately, there's only a limited number of materials got the PASS assessment at the moment, because it's something that the manufacturer has to pay for. But a lot of information on the GreenSpec website, breaks down, similar to the BRE Green Guide does, and similar to the MBS does, if you're familiar with that. Looks at elements, and you can click into these, and it'll bring up certain items that you can read about, and it will tell you lots more about, in a kind of more honest way, about the materials. So that's one option. But what do you do? Do you mix and match these? How do you decide what's sustainable? You know, how do you quantify it? This won't tell you the embodied carbon. And this is the pass. So if you want to have a look at green spec, that's fine. The other thing that you might want to look at are environmental product declarations, EPDs. Now this supposedly is a European standard under ISO 14025, and I don't know what's going to happen to that in 2 years' time, whether it'll even be relevant in this country. But EPDs look at the sustainability and the life cycle, the environmental life cycle of materials, products, and manufacturers can apply for an EPD. Now I'm not going to go any further into EPDs. If you feel like you must read the EPD website, be my guest. It's a quest to get any further than if you have to be really interested in what's going on with it. It tries to look exhaustively at those issues surrounding sustainability of materials, but the manufacturer has to pay for an EPD. So you might declare that your materials must have an EPD, but it has to be a manufacturer that's actually taken time and effort to get an EPD. But GreenSpec will tell you about various EPDs that are available. These are the things that the EPDs take into account. There's a lot there. Looks similar to VRE Green Guide, for a little bit more mind on it. So, where else could we go? Say you haven't got much time to look into that. You might want to ask manufacturer and trade organisations, which, as architects, technologists, we do a lot. We get people to come and talk to us, get reps to come and talk to us. But you risk a lack of objectivity. You risk what's called greenwash. People will turn up going, hey, my product's the greenest thing you can possibly have. I'm old enough to remember the PVC window industry trying to sell you PVC windows on the basis that that would save trees. If you're lucky, or if you're unlucky, you might not be able to find anybody in that company that actually knows about their product and knows about the sustainability of the material. Or they might not even realise they've got a sustainable product. You wouldn't think this was sustainable. I've been going to seminars for 20 years about earth building and timber, and no one's ever sort of put a concrete block there and gone, that's sustainable there. And you can actually buy Enviro blocks. You can order Enviro blocks, and then they tell you about how environmentally friendly they are and how much recycled material you've got in. But in actual fact, there's very little difference between an Enviro block and a bog standard concrete block. Because a bog standard concrete block can have 80% recycled material in. Most gypsum offcuts and gypsum waste from plasterboard plants ends up in blocks. And that's not driven by any kind of legislation or altruism. Well, it is driven by legislation, but not the legislation you might think. It's driven by landfill tax. You know, we drive up to our tip and there's a sign there saying no asbestos or gypsum. So the manufacturer has to find somewhere else to go with it. And lo and behold, there's concrete block manufacturers that need that. So just almost by accident, the humble concrete block is possibly as sustainable as anything else. But there's a lot of block manufacturers not realising that, but somebody's hit on the idea of having Enviro blocks, and they're no different, but they've got a clever marketing ploy. On the other hand, you might have too much information. Now, timber aside, which I love, in the commercial sphere, most of the kind of structural frames that we end up coming into contact with is steel and concrete. And there's been a constant, almost war between the concrete and steel industry about which is most sustainable. Some more aggressive than others. The steel industry in particular has huge amounts of information on why they're best. The concrete centre has some great information as well, and it's fairly objective. For some reason, the steel side isn't. It's very aggressive, and you get headlines like this. Now, I'm assuming people know about thermal mass and passive design and how buildings work, and as far as I'm aware, it's not a myth. And actually, if you read this, it goes on to say it's not a myth. But what they're trying to say is that people misunderstand it. But this headline, a lot of the time, that's what you see. So you get the steel industry saying, "Oh, you don't want to believe that. Well, steel." So which is right? Which is best to use? Well, steel, you can have a high recycled content, but it's always smelted by fossil fuels usually, and iron ore is usually imported. usually from Sweden. Now concrete uses cement. Now in the plenary talk we heard about the possibility of using cement-free concrete. The reason that cement is nasty is that cement production worldwide is responsible for anywhere between 5 and 10% of anthropometric global warming emissions. That's like 10% of all climate change emissions on the planet come from the cement industry. Up to 10%. But, on the upside, you can use the thermal mass of the concrete as a climate modifier. So there's kind of a balancing act to do there. Maybe concrete isn't so bad if we just get rid of the cement. So a couple of people, quite a few years ago now, 10 years, I'm just looking at that, did a study trying to find out actually what is the most sustainable. Korean Brown with Halligan partners, I have time for, did a study, and Faber Morsel did a study as well, comparing the two. And I'm not going to read these out, but the conclusion was, there wasn't any conclusion. The conclusion was, as they said, Faber Morsel said, it's extremely difficult to conclude which material is the better. Both options have their own advantages. Once the frame type is chosen, the developer should maximise the benefits. I've ended up reading it out. The key is here, and this is something that you'll find, it's not so much the material, it's how you use it. It's what you are going to do with it. If that concrete can be applied climate modifier, if you use it in the right context and the right manner, that is almost the key thing to sustainability. Not just getting something and say it's got a green badge on it. So yeah, good and bad. I'm not going to give you any answers here today because there's lots of questions but no simple answers. And it's part of actually finding what the answer is for your particular context. So what's the answer, as I said? Well, see there's all this. What are you going to choose? All of them? Half of them? None of them? Some of them? Pick and choose? That's your main decision when you're trying to assess a sustainable building. And which is why people go back to the BRE Green Guide and BREEAM, because it's a standard you can use and you can say to people, and it's becoming obviously often a commercially demanded standard. I want a BREEAM outstanding building. It might end up in reality being sustainable or not sustainable. I've worked on projects which have been design and build projects, but it's been in the brief to be BREEAM outstanding. And so all that becomes important is the contractor asking me, has that got an A rating? Has that got an A rating? Has that got an A rating? And nothing else matters. And you end up then, you end up with a fantastic rating from your BREEAM Green Guide. Anyway, so that's kind of sets the scene really for a little story. And this is about really some research that I did in around about 2009. And I was asked to come up with a technical assessment, technical solution for an educational establishment in Kent. And the architects that designed it asked me and my team to investigate sustainable solutions, sustainable materials. They'd already largely had in their head the idea of what they wanted it to look like, what they wanted it to do. So I was tasked with finding a whole raft of sustainable materials. And one of the ones we began to look at, one of the key elements was for a structural spine wall. Now the criteria for this was it had to be load bearing, it was monolithic, going to be thermally heavyweight. The first thing we found was that, I've been involved in kind of low energy buildings since mid-80s. And I found all my preconceptions to be challenged because what came about, all the materials that I thought I'd look at, there was a lot of information about, but it was all at the domestic scale, or all I want to consider the enthusiast level. If you're into green building into sustainability, it's almost a commitment and a calling. And the commercial side of things, particularly at that time in 2009, the information at a commercial level for materials was just unknown. And what we found that a lot of things that I started off looking at, the information wasn't there to use in a commercial situation. And when I say a commercial situation, I don't necessarily mean just the size of the building, if it was big. I'm on about people working on a contract to deadlines. and taking risks, and that's what you face with a commercial situation. So we started looking at 3 different materials, and we looked at natural stone, rammed earth, and low carbon concrete. Now, it was in Kent, so we thought, oh, Kent, they have ragstone. Natural material, it's low carbon, it's low embodied energy. You might not be happy if you live next door to a quarry, but you know, taking stone out of the ground and just taking it somewhere, there's not much processing to it. The trouble is what we found out in Kent, ragstone is now largely quarried for aggregate, and it dresses really funny. It doesn't like split into nice beds and planes, so it's very hard to get suitable walling stone. There's hardly anybody in Kent can actually dress it anymore. It was a very traditional skill, and so consequently it's very expensive. It's all right if you own a castle around about 1300, but if you want to build a school somewhere near Dartford, it proved problematical, to say the least. So then we looked at rammed earth. Now this was our preference. We really wanted to use rammed earth. I don't know if you know about rammed earth, but basically it's almost like you form it like natural concrete. You create shuttering, you pour a load of earth in it, you tamp it down, you leave it to dry, which can take a long time. And when the moisture content hits a certain level, you take the shuttering away, and if you're lucky, it stands up. If you're unlucky, that happens. But if it works, it looks gorgeous. This is the Eden project. Some of you might have visited. No, but it's got to be highly sustainable, hasn't it? You just dig the dirt out of the ground, you put it in the shutter. Wow, yeah, okay. So we found out there were 2 varieties of rammed earth, stabilised and unstabilised. But there's a very limited number of practitioners in the UK to deal with rammed earth. In fact, there's just one of each, one for each type. And they're quite factionalised. They sort of argue about which is best and which isn't best. And we talked to both of them. And we found that unstabilised rammed earth, which is, in terms of carbon, the most sustainable. That just means it's earth, put into shuttering, left to dry. It's an extremely long process to create a large load-bearing wall. When I say extremely long, I mean 6 months to let dry. Also, because there's no additives in there, you have to keep it sheltered. So you've actually got to build a building over it to dry before you cast it. And of course, the carbon footprint associated with time and resources on site. You need specialist trades. Now, this is where you come into the commercial side of it. If it's going to fall down, and you stand the risk of it falling down, can you imagine your D&B contractor going, what, you want me to sign up saying that's going to stand up and for 6 months and we're going to be behind and where's my LADs and, oh, no way. And then he'd have to get the single sort of rammed earth specialist to come and teach his people how to do it. You can see which way this is going. So it's, you know, potentially a high risk situation. Then we also found out that our load bearing 7 metre high wall would actually be 1 metre wide, which eats, you know, commercial again with a developer, floor area. Now the other thing as well is that we did find out, you think rammed earth you dig out of the ground, just put it in shuttering. What we did find out is that not all earth can be rammed, and your earth under your site might not be suitable. And we definitely found out that our earth in Kent wasn't suitable. Most of it was full of asbestos. But we get situations like this. This is Akeley Heads in County Durham, and inside here there's this fantastic, I can't find a colour photo, but a fantastic internal unstabilised rammed earth wall, and the material for that came from Cornwall. So I suppose that's local though compared to the locality that maybe some shopping centres were. Anyway, so then we looked at stabilised rammed earth. Now stabilised has nothing to do with putting crops up. Stabilised is putting additive in, which can be cement, can be lime. Traditionally it was animal blood, bone meal, anything like that. So it's this extremely long process. Again, it's still 6 months for it to dry out. But you can construct it in wet weather, so you're not building little shelters over it. But you've got your carbon footprint associated with time. Still going to be 1 metre wide, but the consultant in this country was very enthusiastic to come and tell us how he could build it, because he would be flying in all these people from Australia to build it for us. So, commercial sphere. The risks for a commercial contractor. Used to putting up crinkly tin sheds, can you imagine? Yeah. Well, put dirt in there. We had to look at alternative materials. And it was this thing about the domestic level to commercial level. Different drivers, not architectural, but commercial, economic. So We had a very long argument about it because we all did really want to use it, but bye. So we're left with this concrete. Oh no. So biggest single advantage of concrete, yeah, climate modifier. And I'm quite enthusiastic about passive buildings and using them to cool. But we said about cement, all those anthropometric global warming emissions. But we can maybe reduce that by using cement substitutes, and also then there's recycled aggregate as well. So we began to look then at how we created low carbon concrete. And what we started with was aggregate. And you think, yeah, you've got to use recycled aggregate. You demolish something, and you're left with all this rubble, and it's got to be used as aggregate. So fresh aggregate, not primary aggregate. Very low embodied energy, minimal processing, great, Recycled aggregates, turns out that you've got to crush them, screen them, wash them, grade them, and that because they crush into an angular form, you've actually got to put more cement in to make the concrete work. So, and also if you're not coming from more than 20 miles away, you're wasting your time. So you can use recycled aggregates, but you have to really sort of take a value judgment really and sort of balance it. And then we looked at low carbon, the cement substitute. And in theory there's loads. You use pulverised fuel ash, which is a byproduct of coal-fired power stations. GGBS, which comes from iron ore plants, not many in this country. And then there's really odd things like stent, which comes from the China clay industry in Cornwall. Silica fume, which has something to do with the glass industry in America. Metakaolin, that's oil sands byproduct, great. And rice husk ash, limited sources in Britain. So the first two, yeah, might be difficult on it, we're okay. The others, and we got a certain trade organisation to come and tell us all about it. Not a manufacturer, but a trade organisation. And we asked him, and he told us all about this, and we thought, brilliant, And he told us about pulverised fuel ash, and it's that grey stuff there. And we met loads of this stuff. You go past a coal-fired power station, it's piled up outside. It's used in all sorts of stuff. And it's already using lightweight concrete blocks. And you can use it instead of OPC, ordinary Portland cement. And you can CO2 savings between up to 30%. There's places now where they aren't at that time, but it's actually been used as up to 70% of a cement substitute, particularly in America. We were looking maybe about 50. But we looked at GGBS, and this is like white powder. It comes from the iron and steel industry, which there's not much in Britain. And it's actually already used in some ready-mix deliveries. It prolongs setting time, it creates increased high strength at an early point, usually up to 70% substitute, and it creates like a fantastic, really high quality finish. If you buy like a concrete bench to put on a railway platform, it's probably got GGBS in it because it's all nice and smooth. I thought that's the thing for us. So, where can we get it, Mr. Organisation Man? And he went, oh, I don't know. I don't think you can get it round here. Just go for it. And I was amazed that this guy's promoting concrete, and So another search. Found a concrete supplier almost next door, and he said to us, "Yeah, we can get GGBS. We get as much as you want. We'll get loads." And I thought, brilliant. Okay, well, so we came up with this specification. We used pulverised fuel ash where the concrete was concealed, 50%. At that point in Britain, it was the highest substitute that had ever been done. We used GGBS. Someone had done 50% before, but not on the scale we were talking about. And we found the demolition site that had recycled aggregate, but we decided on using 30% of it. It was kind of sort of tipping point. That was our space. But even that didn't happen. Because as I found out later on, it became apparent, it was shortly before about going to start on site, the manufacturer phoned us to say, oh, we told you get as much GGBS as you wanted. Well, yeah, we can't. And because there's only a limited supply in this country, it was at that point, because people began to look at low carbon cement, it became sought after. And a competitor of our concrete company managed to buy up most of the future supplies for 10 years from the one steel plant it was coming from. And they're actually marketing it now, I believe, as low carbon concrete, but they hadn't geared up for it, they just made sure they got everybody else's. So the actual specification we had was PFA content 50%. I say in America it's gone up to 70 now. Now, that was our sustainable specification, concrete. Nothing weird or fancy or not quite as exciting as I wanted initially, but it was just concrete. But we had to do an awful lot of work to arrive at that situation. And this building, which I haven't got photos of now because it was my past practice, ended up for a short period as being the highest rated BREEAM building in Britain for about a week. It won all sorts of awards. Anyway, just as a postscript to all that, and all I got a view that all this took a couple of years really to get to the end. I was on a trade mission to Shanghai with a major concrete manufacturer, and I was telling him the story. And he looked at me and he went, GGBS, and this was the marketing director of a. If I said this name, you know, everybody in Britain would probably know the name of this this building materials manufacturer. And I told him the story about GGBS. He looked at me and went, GGBS? I went, yeah. He says, is that sustainable then? Yeah. He says, it's just that we have silos full of it we don't know what to do with. we use it as additive if somebody wants it. And if somebody wants it, if an engineer wants it or a concrete specialist wants it. But basically all the people dealing in sustainable design didn't know about it. And they didn't know, the manufacturer didn't know it was sustainable. The people designing didn't know it was there. And he just said, do you think we're missing a trick? Well, anyway. Alright. So, conclusions. Not many really. But obviously sustainable materials might not be appropriate. It's the scale, the type, the form, the way we build, the contract we've got, the contractor you're using, the demands of the client. Mainstream products might be, but they're not even being marketed as that. Yeah? And any product might be the most sustainable in any given context. And finding the information and deciding on your criteria is the killer. But most of all, beware of greenwash. Because there will be people telling you that they are sustainable. And it might just be rubbish. So, not easy, no answers, but maybe it's food for thought. Thanks. Questions?
Did I miss something? Why didn't you build the sustainable, what was it called, the Academy for Sustainable Construction out of wood?
All right, okay. I didn't design the whole thing. Yeah, I was asked to look at materials. Part of the brief, and it's interesting this in terms of sustainability, part of the brief was it was a demonstration project. So they wanted as many different technologies as possible throughout that building. That in itself is not sustainable. Yeah, there's sustainability can revolve around the economics of scale. You know, if you find something that works, you should use that to the greatest effect. But they wanted everything in there. You know, Britain's awash with demonstration projects, and all they demonstrate is that you should like be a bit more guarded in what you choose. Suscon had a lot of timber in it. It had a lot of glulam. It had.
I think I've been there.
You probably have. Yeah.
Yeah, it's got glulam.
Yeah, yeah. It's got wood-based
So
insulation.
Is it called
Suscon.
Yeah.
Yeah. It's got wood-based insulation. So that's the reason. Without going into it, I only had 45 minutes. But if I was telling you about Suscon, I'd tell you about the drivers. Why we ended up just looking at those three materials for the spine wall. So yeah, point taken. You know, did a lot of research. I'd say the research I've shown you on concrete, I could show you something as long for timber as well. So, and the things you find out about timber and where it's grown and what's sustainable and how Russian timber works better than British timber because we don't have sub-zero winters and things. There's a lot. Yeah. And just on that, there's an interesting. Sorry to go on, but the timber. One of the things we wanted to use was sweet chestnut, which is very popular at the time. And I don't know if anybody's seen the house, the Kingspan house at the BRE, shaped like a sail, clad in sweet chestnut, which ended up with black pools of water dripping out of the sweet chestnut in the bottom. Sweet chestnut's a really good, robust material if you just get around like the bleeding of the black stuff out of it. But it's been grown by about 3 guys in small woods somewhere on the south coast. You know, we just could not get enough on a commercial basis to do anything with. So that was the difference between. That's what we started off with, but that was a domestic solution that you will see on grand designs. But trying to get that supplied to a major national contractor to make his windows out of. This wasn't going to happen. So, Niels?
Could have done it in straw.
Could have. And we everything that you're going to say, I probably we looked at straw. We spent a lot of time in mod cell.
Not with mod cell.
Well, that's what we looked at the time. Yeah.
Well, that's what I did, eh?
And the idea was that a huge part of it was going to be straw. We wanted one side of it to be straw, and that wasn't my decision. I can't remember actually why we didn't use it in the end. It was something to do with the availability and what they actually wanted in there, and it didn't
Just
work
went
out.
to the wrong people.
Probably. Should have come to you. So yeah.
Did you look at limecrete?
Yeah, hempcrete. Yeah, limecrete, hempcrete, hemp. Yeah, hemp, brilliant. Love hemp. Most sustainable material on the face of the planet. That on bamboo, you know. It had some hemp-based insulation in. Yeah, there was an issue at the time. It's moved on a bit as hempcrete now. At the time, hempcrete was only available by that spray application. You can't do it all year round. There's an issue with the moisture in the atmosphere at certain times of the year. Well, that's a commercial thing again. You can't say to your contractor, "Okay, just stop for 6 months." You know, now they've gone beyond that to where they're looking at factory-produced panels, and that is a huge thing. That's a huge step forward to me. Is that? But there's something else on with that. You know, we're talking about all these different materials. One of the things that we did face, and one of the problems we faced, particularly around earth, you go to a commercial contractor, and they don't want to use anything they don't have any experience of. Yeah, I've done quite a few buildings out of innovative materials that the QS has looked at and said that's going to be cheaper than anything traditional, you know, concrete, and the contractor's gone, "Oh, I've never come across that before. Put a 0 on the end," and that's what happens. The construction industry is inherently conservative in this country. Doesn't like change. They know how to do things, do it their way. They know how to make their profit, and particularly D&B projects, you will come under massive amounts of pressure to change that. So yeah, we did. Looked at everything. Anything else? Okay, thanks for listening. I hope it was.
Thank you.
All right.
That's great.